Okay, so this will be a very nice exercise on Cayley-Hamilton theorem that states that every matrix annihilates its characteristic polynomial. So let's see. So the question asks this question. You have this A matrix, you see this giant 6-on-6 matrix, and the question is, does this polynomial pt equals t to the power of 6 minus t annihilates the matrix annihilates this polynomial? Namely, if I just apply the matrix to the polynomial, will I get 0? Namely, a to the power of 6 minus a equals 0. Now, Cayley-Hamilton really can help us solve it very easily. You know, this is a upper triangular matrix, right? Because everything from below the diagonal is 0. So for a triangular matrix, the characteristic polynomial is built, the roots, the eigenvalues are the values on the diagonal. So you can understand that all the eigenvalues of this matrix A are just zeros because all the diagonal are just zeros, and this is an upper triangular matrix. For triangular matrix, the eigenvalues are just the diagonal entries. You can just very easily check, calculate a minus lambda I, take the determinant, and you'll get that all the eigenvalues are 0. Namely, the characteristic polynomial of this matrix is lambda to the power of 1, 2, 3, 4, 5, 6, lambda to the power of 6. So the characteristic polynomial of this, here it is, all the eigenvalues are 0, and the characteristic polynomial, if you calculate it, you get just lambda to the power of 6 after you calculate the determinant of, you know, finding the characteristic polynomial. You get t to the power of 6. Therefore, from Cayley-Hamilton theorem, the matrix A annihilates its characteristic polynomial. So a to the power of 6 must be 0 because the matrix annihilates its characteristic polynomial by Cayley-Hamilton. So a to the power of 6 is 0. So can it be that a to the power of 6 minus a will be 0? This, of course, cannot be because a is not 0 and a to the power of 6 is 0. So 0 minus something that is not 0 is not 0. So we can understand quite quickly and quite nicely that a does not annihilate this polynomial. So that's it. That is how we can use, for example, Cayley-Hamilton theorem and looking on the characteristic polynomial to understand things and properties about a matrix that we have. So you saw how we used Cayley-Hamilton theorem, which means that a matrix annihilates its characteristic polynomial. Thank you very much all. If there are any mistakes or corrections, please tell me. That's it for now, and goodbye.